In this video, you will learn about number lines. Now, a number line is simply a line with numbers. But it's not just a line with numbers, there's a pattern and there's different parts to the number line. So we see here we have negative numbers, then 0, and then positive numbers. So 0 is called the origin. Origin simply means the beginning, and it's called the origin because everything starts there at 0. From here, on the right side, we have positive numbers, and on the left side, we have our negative numbers. And notice that it goes in order, right? The more to the right we go, the bigger the numbers, and the more to the left we go, the smaller the numbers. Now with number lines, we can plot different points on here. So if you were told to graph a point at -2.5 and name it point A, you would find where -2.5 is. So that's between -2 and -3, about halfway in between. So our point would be about here, and we would name it point A by writing the letter A above it. So next, you could be asked the opposite. You could be asked, what is the coordinate of point B? So all you're doing is you're just telling me where is point B. So when it says coordinate, that means where is it? So point B is at the number 3, so the coordinate of point B would simply be 3. Now number lines can be used to represent any sort of information, and so here are some examples where you need to decide what number would best represent the given information. So for example, the temperature rises 10 degrees. What number would represent that? Well, it's a rise of 10, so it's a positive number. It's increasing, so it's going to be a positive 10. A temperature drop of 10 degrees could be represented by a negative 10 because it's going down 10. Or maybe with direction, 6.5 miles north. North is up, which is typically a positive direction, so that could be a positive 6.5. 6.5 miles south would be going down, which would be a negative 6.5. And maybe we could talk about wages, so how much you're earning for a job. So maybe a wage increases by $22. So if it's increasing, that would be a positive number, so positive 22. If it's decreasing, then it would be a negative 22. And for each of these, we could put this on the number line to represent this information. Now with numbers, there is what's called the real number system. And believe it or not, there's actually what's called an imaginary number system. But that is going to be more in Algebra 2. So with the real number system, this is basically any number that we have learned or that we use on a day-to-day basis. So with the real number system, we have two main categories. We have rational numbers and irrational numbers. So rational numbers would be anything you could write as a ratio or as a fraction. So for example, we have -2. You can write that as a fraction because that would be -2 over 1, same thing. 0, 4, 4.5, 1/2, those would all be rational numbers. Even this one where it says 0.3 repeating, so 0.333 going on forever, that is actually a rational number. Anything that's repeating is rational. And in fact, this would actually equal 1 over 3. So that is a ratio, that is a fraction, so therefore it's a rational number. Irrational numbers would be things that cannot be written in a ratio. So for example, pi. This is used in geometry. Pi is irrational. It is 3.14159, etc. Keeps going forever. Another example would be any sort of square root or any sort of root that does not work evenly. It's not a perfect square. So like the square root of 4, for example, would equal 2. Okay, that's a rational number. But the square root of 3 is not a perfect square. That'd be 1 point something. So that would not be rational. That is irrational. The square root of 10 is irrational as well. Anything that's not a perfect square is going to be irrational. So that means it's going to keep going forever. And then we see 0.6843, and we see the dot 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 at the end. That means it keeps going forever. So anything that keeps going forever, any decimal that does not end, would be irrational. Okay, then under the rational numbers, we have more types of numbers. We have integers, which would be anything you'd see on the number line. So all those tick marks that we had, like -3, -2, -1, 0, 1, 2, 3, etc. Those would all be integers. So an integer is any number, really, without a fraction. So not like 1/2 or 1/3, just a regular number. Okay, more specifically, we have what's called whole numbers. So whole numbers are types of integers, but here whole numbers include only numbers starting at 0 and then all the positive numbers, 1, 2, 3, 4. And once again, without having fractions. And then natural numbers would be starting at 1, going all the way up to infinity. So like 1, 2, 3, 4, etc. So some ways you can remember whole numbers and natural numbers. Whole numbers, you see the word whole. Okay, it can also in English mean a literal hole in the ground. So we see the number 0. 0 looks like a hole. Okay, so if it's starting at 0, that's going to be whole numbers because 0 looks like the hole. And then natural numbers, it's kind of a dumb way to remember, but you think of a baby. When they're born au naturel, right? So babies, or small children, when they learn how to count, they start with 1, right? You teach them 1, 2, 3, etc. So the natural numbers is basically when you first start how to count as a small child. You start with 1. So 1, 2, 3, 4, etc. Now with numbers, we have a way to compare numbers and showing which one is bigger, which one is smaller, which ones are equal. So here we have inequality symbols. And these are symbols to show which numbers are not equal, and I guess comparing two or more numbers. So it's showing the relationship between two values that are not equal. So that would be things like greater than or less than, and those are the two main ones we'll discuss today. So the symbols look like this. So this symbol here in red means less than. So for example, 3 is less than 8. Okay, this would be a true expression showing that 3 is smaller than 8. And in English, we can say this as 3 is less than 8. Another symbol is the greater than symbol. So the greater than symbol looks like this. And using the same numbers, 3 and 8, we could say that 8 is bigger than 3. So this would be the math notation. And in English, we would say 8 is greater than 3. So notice that the mouth of the inequality will always face the bigger number. So if we imagine this as being a mouth, you can draw teeth and a face if you wanted. The mouth is facing the bigger number. So here, the mouth is facing 8. No matter which side the 8 is on, 8 is bigger than 3. So the mouth will always be facing 8. And then, if you want a way to remember which one is less than and which one means greater than, a way you can remember that is that the less than, so less than, points to the left. So less than points to the left. L, L less than left. So it's pointing to the left. So imagine that as like an arrow. Okay, it's pointing to the left. So that could be a way to help you remember which one is less than and which one is greater than. Now we'll finish with a few examples where you have to determine if a statement is true or false. So here is the first statement. Is this true or is this false? Well, notice that the mouth should be facing the bigger number, and the mouth is facing the 8, so this would be a true statement. And in English we would say 0 is less than 8, which is true. Next we have this. Is this true or false? Well, in English we would say 4 is greater than 3. And that's true, so our answer is true. And notice again the mouth is facing the bigger number. 4 is bigger, so the mouth is facing the 4. Next we have this. Is this true or is this false? Well, in English we would say -1 is less than 3. That is a true statement, and we can also verify that because the 3 is bigger and the mouth is facing the 3. So therefore it's a true statement. Next we have this statement, and the question is this true or false? Well, in English we would state that -2 is greater than 8. That is not a true statement, so the answer is false. And notice 8 is bigger than -2, so the mouth should be facing the 8, but it's not. It's facing the -2. Next we have this statement. So this in English would be stated as -5 is less than -1. -5 is smaller than -1, so that is a true statement. And we can verify because the mouth is facing the -1 and -1 is bigger. Next we have this statement. In English we would state that -3 is less than -4. That is not a true statement because -4 is smaller. -4 is more negative. So it's not a true statement, so therefore it would be false. And lastly, we have 1/3 and 1/2, and in English we would say 1/3 is less than 1/2. Now that is a true statement. 1/3 is smaller than 1/2. So this one would be true.